Let's go ahead and get started. We're going to be working on solving linear equations and inequalities. The first problem that we will work on has to do with just proving that this particular x equals -2 is a solution of this equation. So what we want to do is we want to plug in the -2 and see if we get a true statement or not. Okay, so I've plugged in -2 and I just need to evaluate this problem, and we have a -2 to the third, which gives us a -8, and then a minus in front of a minus gives us a plus, and we end up with a -8 plus 8, which is equal to 0, and that checks out. So that means that yes, we have proven that -2 is a solution. Our next problem, we need to solve for x, and first thing I'm going to do here is I'm going to get rid of my parentheses. I'm going to distribute in the 2 here, and I'm going to distribute in the 3 here, and then start solving for x. Okay, so let's go ahead and combine our like terms. I'm going to go ahead and start on the left-hand side of the equation. A 4x and a 3x is going to give us 7x, and then a -6 plus 3 gives us a -3. And at this point here, I want to pull all the x terms to one side and then all my real numbers to the other side. And so I'll subtract a 5x to both sides here, and I'll add a 3 to both sides here. And we have a 2x is equal to 5, and that gives us, if we divide both sides by 2, that gives us x is equal to 5 over 2. This next problem here, it's a little bit more difficult simply because it has some fractions there. Some people like to get a common denominator and deal with it that way. I like to just get rid of the fraction altogether and put it in the form of the problem 2. And so the way that I'm going to get rid of the fraction altogether is to just multiply by the least common denominator. So the GCF of the denominators, which happens to be 8. So I'm going to multiply both sides by 8. Multiplying both sides by 8. Okay, so multiplying both sides by 8 gives us the ability to cross off each one of the denominators. Here we have 8 over 8. That crosses and gives us a 5y minus 2. And we have a 2 times 8 here, which gives us 16. And then here we have a 8 divided by 4, which is 2, so we have a 2y here. So by multiplying by the least common denominator, we now have a problem that's really easy, right? And so if I subtract 2y to both sides and add 2 to both sides, that gives me a y equals 6. So I skipped a few steps there. Hopefully you're okay with that. Okay, so now we're going to solve a linear inequality, and instead of solving simply just for x equals one particular number, we're solving for a certain range of numbers here. And so I would like us to get some practice writing our solution in interval notation. So let's go ahead and just solve this problem as if it were an equation, and then get some practice with the interval notation. I'm going to start off by distributing the 3. Okay, so I have come down to the point of -2x is less than or equal to 7, and at this point I need to divide both sides by -2, and that means that our inequality sign is going to flip. So we have a x is greater than or equal to -7 over 2. And let's go ahead and think about that in terms of interval notation. We have -7 over 2 here, and we're talking about x values that are greater than or equal to that value. So we're talking about the values to the right here. and that means that we're going to include negative 7 over 2 and go all the way to infinity. So any value that we plug in from negative 7 over 2 all the way to infinity is going to satisfy this inequality. Alright, so on this problem here, once again, we have some fractions, and let's go ahead and simplify the problem first by just getting rid of the fractions. We got to multiply by the least common denominator, and so we have to figure out what the GCF of 3, 2, and 4 is, right? Which is 12. So let's multiply both sides by 12 to get rid of each one of those denominators. So multiplying both sides by 12 gives us this inequality here, and now we have the ability to get rid of each one of these denominators. 12x over 3 is going to give us a 4x. 12 over 2 is going to give us a 6. 12x over 4 is going to give us a 3x, and then that gives us a 4 there. So now if we subtract 3 to both sides, we have a 1x, and then if we subtract 6 to both sides, we have a negative 2. And let's write our solution in interval notation. We're talking about all the values greater than negative 2, not including negative 2, just greater than negative 2, like so. And the actual graph looks like this. First period has agreed that you don't need to do this problem, so we're going to go ahead and skip over it. You can thank them. We are going to do this one though, and the reason behind this one here is because the reason why I want to do this one is because of this negative right here. This negative really trips a lot of people up. I can't tell you how many times even honors pre-calculus students fail to distribute the negative. It's a big common mistake. So whenever you have a negative in front of a rational expression, remember a rational expression is just essentially a fraction that has unknown values like x. Whenever you have a negative in front, you have to remember to distribute the negative to the terms in the numerator of the rational expression. So I always like to just get rid of that negative from the very get-go so I don't forget about it at all. And this is a 4 over x is less than or equal to 9 over 5, and we're going to distribute that negative, so I'm going to just replace a plus and write a negative 7x plus 4 all over 5x now. And at this point here, I want to get rid of my denominators once again. If I can get rid of my denominators, this problem's much easier. And so I'm going to multiply by a 5x on both sides to get rid of each one of those denominators. Okay, so now we have the ability, what did I do there? Now we have the ability to cross off some of these values, like the x here, and then the 5 here, and then the 5x here. So that gives us, right here we have a 5 times 4, and we have a 9 times x, and then we have a minus 7x plus 4. And so let's go ahead and solve. We have to subtract 4 to both sides, and then we have to divide both sides by 2, so that gives us x is greater than or equal to 8. And that takes us from 8, including 8, all the way to positive infinity. So please don't forget to distribute that negative. I can't tell you how many problems. I think this was taken from the first test maybe of last year. Can't tell you how many times people just give the negative to the 7x and not the 4. It happens all the time. I see people do something like this. Alright, you need to distribute to the entire quantity up top. See ya. Okay, so one part of the class that I want you guys to work on is Khan Academy, and I want you guys to work through what's called the Artist and Algebraists 1, 2, and 3, which just gets you your wheels turning for pre-calculus. So what you need to do is you need to log into the Khan Academy, and you need to actually create an account for yourself if you haven't done so already. And you're going to, once you've logged in, you click on your name in the top right hand corner, and you're going to go to the profile page, and you're going to click on badges in the left column. Then you click on Moon Badges, and then you're going to select the Artist and Algebraists 1, 2, 3 with the green tab. Once you've done that, you can find the Artist and Algebraists problems under the Goal tab in the left column. So to just give you an idea of what you're going to be looking at, here is my profile page, and what I've done is this morning I decided to try the equations here, and I literally did it in like 3 minutes. All I had to do was get through 5 problems in a row in order to complete that particular problem set. That one is a really easy one. There are others that are a little bit more difficult. All I want you guys to do is to complete each one. Okay, so as soon as you see the line through it, you're done with it. Move on to the next one. Okay, so some are more difficult than others, but if you click on any one of these, like inverses, you see once again you just need to get 5 in a row to complete. Okay, so it's really not that bad. If we haven't covered a particular topic, we will, don't worry. We'll get there in Chapter 1. Like inverses are in Chapter 1. And I'd like us to set a tentative date for completing these by the end of the first grading period. And that gives us a long time. Alright? Are we all good on that? Okay. So if you guys have any questions, please let me know. I think I've given ample time to work on that stuff. If you have any problems, let me know. Okay? It's good practice, it really is. You guys know Vin? You guys know Vin? He did all of them in like one weekend, and then he like started the calculus ones and just worked through so many. So, anyway.